Problem number 48, page 632, equilibrium section of the text. So we're given this balanced chemical equation, and we're told that there's 8 moles of NO2 placed in a 1 liter container. It then dissociates into NO gas and O2 gas. Dissociate just means breaks up. Then at equilibrium, we are told the concentration of NO gas is 2.00 molar. We need to calculate the equilibrium constant for the reaction. Since we're asked to calculate the equilibrium constant for the reaction, we need to write an equilibrium expression from the balanced chemical equation. Now to solve K, the equilibrium constant, we need the equilibrium concentrations of all the gases. We're given the equilibrium concentration of the NO gas, 2.0 molar. We are not given the equilibrium concentrations of NO2 or O2. We are, though, given the initial concentration of the NO2 gas being 8 molar. 8 moles in 1 liter is 8 molar. To solve this problem, we're going to need to set up an ICE box. ICE stands for Initial Change Equilibrium. To set up an ICE box, you need the balanced chemical equation and you need the ICE on the left. First, I'm going to write in the initial concentrations of the various chemicals. Since I was told that we start out with 8 molar NO2, I wrote that in there. Then, since the reaction hasn't started yet, initially we have a 0 concentration of the NO gas and a 0 concentration of the O2 gas. The change in concentration that's going to occur is directly related to the stoichiometric coefficients in the balanced chemical equation. So the change of the NO2 gas is going to be minus 2x. It's minus because the NO2 gas is a reactant and it's going to be used up. And it's going to change at 2x because this stoichiometric coefficient is 2. So every 2 moles of this that breaks apart, you're going to make 2 moles of NO and 1 mole of O2. The change of concentration that's going to occur with NO2 is positive 2x. It's positive because the NO gas is a product, so it's going to be produced. The O2 gas has a change of concentration of positive x. Stoichiometric coefficient 1, 1x. To determine the equilibrium concentration, you just have to combine the initial concentration with the change in concentration. So 8 and then minus 2x is the initial concentration, or the equilibrium concentration for the NO2 gas. We were told that the equilibrium concentration of the NO gas is 2 molar. And then the equilibrium concentration for oxygen is going to be x. 0 plus x is plus x. So this is an ICE box, and let me just go over once again what everything is. You need a balanced chemical equation. You need information, the initial concentrations if possible, the change in concentration, and that's determined from the balanced chemical equation. And then the equilibrium concentration is the third row. Now to calculate K, we need the equilibrium concentrations of all of the gases. Since we were given the equilibrium concentration of the NO gas and the initial combined with the change gives us the equilibrium constant, 0 plus 2x equals 2. 0 plus 2x equals 2. Knowing this, we can solve for x being negative 1. We can then substitute this x in for here, this x, and then we'd be able to determine the equilibrium concentrations of the other gases. Substituting 1 in here, 8 minus 2 is 6, so the equilibrium concentration of the NO2 gas is 6 molar. Substituting 1 in here, the concentration of the O2 gas is 0.1 molar. And we were given the equilibrium concentration of the NO gas. Now to calculate the equilibrium constant for the reaction, we just need to substitute in the equilibrium concentrations that we just determined into our equilibrium expression. Substituting in the equilibrium concentrations and calculating, you should be able to determine that the equilibrium constant for this reaction is 0.11 molar. Any questions?